Okay, so we're going to talk more about functional programming. We've seen lots of examples throughout, but we haven't necessarily focused on it. And then on Thursday, we looked at lambdas and list comprehensions. So we're going to add some more functional programming tricks or patterns. So we'll start with a little refresher about purity and how that works with testing. So we've seen this a lot, but we'll just hit that again. We'll talk about closures because closures are basically the mechanism that allows a lot of more advanced functional programming techniques to actually work. And then we'll talk about decorators and generators. So we've seen, we've talked a little bit about decorators, some initial exposure, and we, in fact, use generators all the time in Python, but we haven't talked about what they are, how they work. So in the spirit of painfully reminding you that we still have to do JavaScript at some point, we'll start with a JavaScript example. All right, so can everyone see my screen? All right, so we have a function here, and we're going to end up writing tests. So we're talking about purity now. So we have this function, add one, it takes in some amount, and then it will add one to that amount, and then it will return that number. So we're going to go and I like to use Jest as a testing library. So in order to do that, I'm going to need to create a node project. How do I get started with a node project?
You have to initialize
npm init.
Mm-hmm. Yep.
Yeah.
So it's
and
like
what?
Yeah. So npm init, and then I'll add the -y flag that will give me all the default answers, so I don't have to do that since this is just a one-off thing. Okay, and that creates, basically all that does is create this package.json file. And once I have that, if I want to install Jest, how do I install Jest?
You have to know what the name of the package is exactly, and then
Right.
you can do npm install Jest.
Okay. We'll do Jest. You could also, I mean, so this will work and that's fine. You could also add a flag called save dev to tell your project that this is, testing libraries typically you don't need when you're building your project for production, but it's a minor detail in our case. So that'll take a minute to install. And then just based on reading the docs, you would know that you have to add this here. So when you run npm run test, that Jest will take over and do its Jest thing. And then we'll add a test. So again, looking at the docs, there's a naming convention. So we'll do so that's just what we'll call it. And again, this is just from reading the documentation. All right, and then in order to import, so we have to export. So unlike Python, we have to explicitly export stuff in JavaScript. And we import it, we do okay. So now we've imported this function because it's the default export we don't have to specify anything. Okay. So again, from reading the documentation, I know that I can create a function called test and a function called test, and that takes two parameters. One is the doc string, and the other is a callback function. And this callback function we'll use, we'll call another function here, expect, and this will pass in, again, two parameters, which is the function that we want to call. So add 1, and we'll try to add 4 to 1. And we expect that, I'm sorry, I think this actually just takes one parameter. I can double check that, but, and we add 2b, and then 5, right? So if we add 1 to 4, we expect it to be 5. So if I did that right, I should be able to run npm run test. Okay, so it looks like that worked. Okay, great. So now I'm pretty confident that my code is good, right? So I pass in a number, it adds 1 to the number, and then returns that increased number. So let's write another test just to be sure. We'll try to cover like an edge case or something. So another test, and then let's do like -1. All right, so it's -1 should be 0. So if we add 1 to -1, that should be 0, right? So let's go ahead and run our test again. And it looks like we have a failure. So let's take a look. So one test failed and one test passed. So our first test passed, but our second test, for some reason, didn't pass. So it expected 0, right? Because we told it to expect 0, but it received 4. So add 1, when I called add 1 with -1, for some reason, it returned 4. Does anyone?
It's it seems like num is being set to 5 by the first test, and then it's using 5 instead of 1. It's not going back to line 1 of your file there to set num to 1 again.
Okay, let me try, maybe we can fix it by doing something like this. Let's see. Let's try this. Oh, cool. So I've fixed the problem. So now our code is working. Is our code good now? So I've written 2 unit tests and now they both pass. So my function works, right?
Yeah, but you kind of made it to work.
Okay, I did make it, but I mean, this is objective, right? Objectively, I have 2 unit tests. So this proves that my code is good.
But it only works within that context where
Right.
you have that let num as a global variable.
Okay, so let's try adding another unit test. Okay, so now that fails. So this test, it expected 4 and it received 8. How? So someone tell me what is happening here. So what is num? What kind of variable is num?
It's a global variable.
Yeah.
It's outside of a function.
Yeah, it's a global variable. So this function is changing a global variable, right? So is this a pure or an impure function?
Impure.
Yeah. So what other things can make a function impure?
When you're using something like console log that's outside of the code.
Okay. So if you are creating a side effect, right, then your function is impure. And a side effect could be lots of different things. Basically, a side effect means you're changing something outside of this function itself. So if this function is doing things, is altering anything outside of itself, then you have an impure function. That could be writing to a file, writing to standard output, making an API call, or anything. And of course, all those things are necessary. So, you know, you can't have everything be pure. But in this case, one other way that a function could be impure is that if it alters a global variable, it accesses or alters a global variable. So one of the reasons you want to have pure functions, if as insofar as that's possible, is to make unit testing easy. And if this was in a larger code base and this is a global variable somewhere and this function was working, maybe sometimes it works and sometimes it doesn't, but it becomes very unpredictable. So if we had, hundreds of thousands of function calls or different components for using this, we would start getting errors and it might be difficult to figure out exactly what's going on. So you might get an error output that's something like, you call a function and you expect it to add 1 and it adds 4 randomly. So it's difficult to isolate the problem. So, and also as we mentioned, these tests are no longer really independent. So the order of the tests all of a sudden becomes important because there isn't referential transparency, right? So this is another functional programming concept. It's related to purity, where you want your functions to be referentially transparent, which means, a very fancy way of saying that when I give it, every time I give it a specific value, it returns the same value. So if I pass in 1, every single time I pass in 1, it should return 2, right? So your function could almost be summarized as a table, right? Like a lookup table, where if my parameter is 1, I just reference the lookup table and what is the return value. But here that's not the case. Here the return value is dependent on all kinds of other things in the environment. Okay, so that's just something to be aware. So that's purity. I just want to hit that again, so we're still aware of the importance of purity, especially with unit testing. All right. So let's talk about closure. So we'll do this in JavaScript as well. So can anyone tell me what a closure is?
Is it just like an open and close bracket?
So there's a block scope in JavaScript. You can indicate with a open and close curly brace. But a closure is a little different than block scope. Let's see, Deb, have you ever heard of a closure before? Deb, are you there? Okay. All right, so that's fine. Closure is a more advanced concept. We've mentioned it a couple of times, but the way it works is,
Well, just like from, I was just curious, just like get a gauge of how hard this one.
The biggest, I mean, obviously the biggest part is trying to, so to
So-
wrap around.
sorry, what was that?
Yeah, like the first time I did this one, I didn't realize.
Deb, are you?
I think I
Let me mute Deb, sorry. Okay, so we have a counter function, and this function returns another function, right? So we have this counter function,
7-minute break.
and
be
there's
back at 8:55, and then we'll go into bubble sort.
Deb. Thank you. So we have a function, and we have this variable that we're creating within this function scope. Then we're creating another function, and we're returning this function. So we should expect, normally when we execute functions, we execute the function, and once it returns, that function disappears, right? It gets garbage collected because there's no longer any reference. It's done its job, it's executed, and then it disappears. In this case, once we return this function, this outer function has done its job, right? So it should just disappear, should be garbage collected. But there's a special condition in JavaScript and Python, which will create something called a closure. So if we have an inner function here, we're returning this. If this inner function references something in its parent scope, it will basically keep it won't garbage collect it. It will keep a reference to it. So it's kind of an exception to the normal process. So we can actually access this value, and it will be preserved. So we will call this function, we call the counter function, and it returns inner. And the first time we do that, let's go ahead and run the function. So we're creating, we're calling this function, right? And this returns another function. So we haven't called this function yet, right? We haven't called this inner function yet. But here we call it, and the first time we call it, this has access to this value out here in its parent scope. So it returns 0 the first time. Then it increments, and that value is stored still. Because of the closure, this value is updated and a reference to it is preserved. So when we call this function again, C has been updated. And we can keep doing that. So we've talked about a little bit about private and public methods and classes. So in JavaScript and Python, this is basically the only way to create a truly private variable, because there's no way for me to directly access this C. There's just no way. I can't do, counter.c. I can't directly change it. I can't reassign it a value. I can't really do anything to it. I can only call this. Function. I can't decrement it, right? So this is a truly private variable here. So let's look at the debugger real quick. And we can see all this stuff over here on the side. All right, so we'll step through. So VS Code will help us out here, and it knows about closures. So we can actually see what's happening inside a closure. And in this case, C is 1. And then when we actually return the value, it should be 0. And we get the same thing. So this closure now has been updated. C is 2. All right. So that's the basic idea. So JavaScript will remember a reference to this. Now, what if we do something like this? So we create another variable just in the same scope as C. So we might expect, if we know that, okay, maybe JavaScript is making an exception when you have a function inside of a function. So let's look at what the value of x is. We'll run the debugger. And I'm just going to add, so you can add, if you want to pay special attention to a couple of variables here, you can go into the watch tab or whatever and add those here. So I'm going to look out for C, and I'm going to look out for X. Okay, so right now, because we haven't run it, we're getting an error here, but that's fine. So if we run this again, 1 second. Okay, so you run the function, and now we're looking at C. So now C is 0. And so let's step over. So we have our closure here, and C is 2, but there's no X, right? X doesn't appear anywhere. So again, this is just something that JavaScript is doing under the hood, but it's not going to just keep everything here. It's smart enough to figure out, okay, is something in the outer scope being referenced in this function? If so, then we'll keep it. Otherwise, you just do what it normally does. So this will be garbage collected because there's no other reference to it in this function. If we did add something like that, now we get a reference to both of these. All right, are there any questions about that?
Yeah, I'm not entirely sure how like the JavaScript interpreter works behind the scenes, but is it that it's in the inner function, or like what if you returned the inner function like plus X? Would it keep it alive then? Like instead of putting it in the inner function, if you just returned inner plus X?
Let's see. Let me try that again. It's not liking that.
Or maybe that's not possible. I don't know.
It should. So I'm returning a function plus x. So this is actually, yes, this is a slightly different problem, but JavaScript is actually going to give you like a literal string. It's going to convert this into a string. It's going to type coercion into a
Okay.
string. So this is actually going to.
That's not even a, yeah.
It won't be a function that's callable anymore. Yeah, there might be some way to do what you're doing, but I don't know if I can.
Yeah, I was just curious, like if it's garbage collecting it because it's unused, or if it's entirely because of like the closure principle. That's all I was wondering. And
yeah,
that's probably a bad example, but
yeah, I am also not, I don't know the nitty-gritty details of how the garbage collector works in JavaScript. Okay. All right. So I think that's the basics of what a closure is and how it works. All right. So let's start talking about decorators. And we'll switch back to Python. So I added this README. So if you want to you can review this later if you'd like. So I'm going to, let's start off by, let's say we have a function. And this function is going to like 0 pad numbers, right? So if we want all of our numbers to be, 3 digits long or whatever, we give it a number. And if it's not 3 digits long, it adds a 0 to the beginning. We can test this out. Okay, 0, 7, 8. So it takes in the number of, basically the number of slots or the number of places, and then the actual number, and then converts this into a string. And that's it. So the specifics of how this works doesn't really matter. Okay, so this works and it's fine, right? So let's say I have an application. Actually, this is, let me see. Yeah, okay, so let's say I have an application, right? And I find that 90% of the time I'm padding 3 places. So I have this general function right here, which can kind of pad anything, but I find that my use case is actually more limited most of the time, right? So it would be nice, it might improve the code readability or maintainability if I could just have a function called like pad3 or something like that. So one thing we could do, if we find that we're, one of these parameters is almost always a particular value, is we can just make this a default. So we can do something like this. And then if we, I need to change the order here. If we call this function now, and so this is a sensible way of handling the use case where you find that almost all the time your a parameter is going to be a particular kind of value. So again, that works, but then I'm still calling it. This is maybe not calling this function is not maybe entirely expressive of what I'm actually doing. So I'm still using this general function to achieve something that's more specific. So maybe I could write another function. So I could just, I'll do something like this. I'll just have another function called pad3. And I can keep it like this. So we run this, and we have, when we want to do this, have this specific use case, right? This common specific use case, we write another function. And so it has a name, so it's clear what we're doing in our code. And then if we don't do that, then we just use the more general function and tell it specifically what we want. So again, this will work, but now we're repeating ourselves, right? So we've got some more maybe specificity or clarity, but we've sacrificed code repetition. So is there a way, rhetorical question, is there a way to somehow keep this general function, but also in our code, make it clear, that we have a specific use case? So let's go ahead and take a look at this. So I'm going to comment this out, our original function, and this is a slightly modified version. So in this modified version, it's still called pad, but now this function doesn't just return a value, it returns a function, right? So now pad is a higher order function. So higher order functions either take in another function as a parameter, and or return a function. So this returns a function, it's a higher order function. This inner function, which is not a great name, but couldn't think of anything better. So this inner function will do basically what our original pad does. The difference is that we've essentially split up our parameters. So now if we want to call pad we can't call it like this. We can call it like this instead. I think I got those switched. Good to know that that works. Okay, so now I've done this, I get the same result, but I've done this, it's a bit weird now, right? So I've like, what? Now when I call it, I have to use two parentheses. So what is pad 5? Yeah, what is pad 5?
Function?
Yeah, yes, it's a function. So I've called pad with 5, and then I'm returning inner. So what happens when we call a function and then we finish returning it? What happens to the local variables in a function?
They usually get garbage collected, right?
Yeah, they do, unless your language has closures. So slots is, although it's a parameter, it's basically a local variable. And because this inner function is using it, the Python interpreter will keep a reference to it. So slots will not disappear. So pad 5 returns this inner function, but it doesn't just return this inner function. It returns this inner function plus a reference to slots. So then when I call this inner function with 78, num is 78. And then I can still reference slots, which came from the closure, along with num, and I can return everything as normal. So this works, right? So I could do something like so if I wanted to, if I wanted to use this function, I could call it just like this. But if we find, for example, that we're consistently, let's say, pad 3, we're always calling it with 3, or what we can do is kind of preload. Right? We can preload the function, which is what currying is. So currying, or partial application. So partial application is a more general term. Currying is just partial application with a single variable. But we can preload this function. So with pad 3. So I'm going to call pad 3. So let's look at what pad 3 is. Okay, so pad 3 is a function, as we expected. So now anytime I want to use, anytime I want to have a three pad, I don't know, three digit padding, I can use pad 3, and I think I need to print that. This works. And what if I have another, what if it's not just one? So like our initial solution was to add a default parameter, right? But what if we have like 2 or 3 very common use cases? So let's do pad 5. And it also works. So we haven't changed, once we create it, we haven't changed pad. So now pad is a general, it's a generally useful function. It still has all of its general applicability. It's not really specialized, but we can specialize. Specific use cases and give them meaningful names, and then use them later in our code. So this is one reason. So this is functional programming. So I would think of this as like a subclass. So pad is like a class, right? And then we can create subclasses that are more specific to what we need. So this is one way that functional programming achieves code reuse. So, you write a more general function, use currying to create more specific versions of that. Okay, so that I don't know why I have this under decorator. I was confusing myself. This is currying, not for decorators. Although decorators have a very similar kind of approach. So sorry about that. I kept I knew there was something wrong, but I kept ignoring it. So this is currying. Okay, I think I'm gonna spell it currying. So currying or partial application. All right. Now for decorators, I apologize. Yeah, are there any questions? Okay. So I'm going to create. All right, and decorator. So decorators are a way of, again, kind of specializing or changing the way that a function works. So a decorator will, the syntax for Python is very, it's very short and sweet, but what's actually happening is that it's just a higher order function. So a decorator is a function that takes another function as a parameter. It does some stuff, and then it will return that function that's passed to it. So just like, just like currying. So the structure will be very similar. So this is a completely contrived example. I know nothing about finance or stocks or anything like that. But let's say we have a function and we're accessing a database or something, right? So you call the function, you pass it like an asset ID or something like that, some reference, and then a value, and then it calls the database, does some database logic, and submits a request to sell a particular thing. I think probably a better, I'll keep going with this example, but probably a better example might be something like buying something on a website. So I click, purchase, and I don't want to be able to click purchase 10 times and get charged 10 times on my card, right? So we can actually write a function and then specialize that function to only be called once. That's what we're going to do here. So we're going to write a decorator. So we have this sell function, which is just a general function. But we want to write a decorator. And we want to write a decorator called once. And with this decorator, again, we can see that we have a function that takes in another function and returns a function, right? So once takes in a function. Here's a local variable, which will be preserved because of closure. And then this function returns this inner function, right? And this inner function will return whatever this function with the arguments returns. So we have this inner function, and so what does this star operator thing do?
Star means that you can take in multiple arguments. You don't have to specify a number of arguments to take in.
Yeah. So so we're keeping this general. We could specify one argument or whatever, but the way we've written it, that this can decorate a function that has any number of arguments. So one difference between Python and JavaScript is that you need to tell Python what this called is, so it won't think that this is a brand new variable. So you can do, there's also global, there's global and non-local. So because this isn't a global variable, right? It's non-local. It's inside of another function. So use the non-local. So all this is doing is saying, hey, Python, called is actually this called. And then we'll check called if the function has been called, and we'll change this to true because it will have been about to be called at this point. And then we call the function and return it. Right? And because of the way closures work, this value will be preserved. So this value will have been changed from false to true, and it will stick around. So the next time we call it, this will be called will be true, and this will not be reached, and we'll get an exception instead. So how would we actually use something like that? Move this down. So we could do this in a couple different ways, just like we did with the currying, where we call the function, kind of preload it, and then do all that stuff. But Python has nice syntax for this use case called it's decorator. So it's @ and then whatever the name of the function is. So what we're saying basically, hey, Python, anytime you call cell, I want you to basically call once and pass it cell. So this is an outer wrapper or a decorator on this function. So if we call cell, yeah. So we call it and it executes normally, right? That's what we expect. What happens if we try to call it again? We get, so the first call goes through, and the second call, I get an exception. So you'll see decorators more when we get to Django. But although this looks, this really abstracts away what's actually happening. What's actually happening is this. So this is just a higher order function. So decorators are just higher order functions. They take a function, they usually modify something. I mean, there's all kinds of use cases, but so once is modifying the functionality of cell. So we don't have to change cell itself, right? We can keep this function the way it is. We don't have to add this logic in the cell, and then we have a cell once, and then a regular cell or something like that. And we could reuse this once functionality in lots of other components, right? So that's why you would want to do this. So maybe there's, we have 50 functions in our application, and 10 of them, for whatever reason, should only be called once. So we can decorate all those functions with this instead of adding that logic in 10 different places.
Chad,
Yeah.
I got lost. Why did cell the second time you call it return an error?
Yeah, so great question. So we have cell, it's decorated with once. That means that when I call cell, what Python is actually doing is calling once, and it's passing in cell, right? So now this f is cell. Call this false, and this will return this inner function. And this inner function will get called with the arguments that we pass it, in which case, in our case, is these two, right? So args is going to be 1, 2, 3, and 1. Then what we're going to do in this inner function is check if this called variable, has it been called? The first time it hasn't been called. So then what we do is we change it to true, so that the next time we won't be able to call it, right? So we change this to true, and this called value is preserved because it's in a closure. And then we return cell, which is F, and the args, which is 1, 2, 3, and 1, right? So that's the first time this happens. So now we've called this successfully, but called is set to true. So the second time that we call it, again, it's gonna pass this function to once and so on, but called is now going to be true. So because called is true, this condition won't be met, and we're gonna fall through, and we're gonna raise the exception.
So you, in this case, just you actually programmed in that it would show an error. It's not that we did anything wrong with the code. Instead of using
No, yeah,
a
yeah, I
print,
just,
for example, you just changed it to be an actual error.
yeah, this could be anything. I mean, we could. So we can call this however many times we call it. We'll just say hi.
And when would it actually get kind of reset and cleared out again? Would you have to, anytime you rerun the file itself is when it gets.
Yeah, so this would be, like, so again, this use case is kind of contrived. I should have thought of probably a better example, but yeah, so something like a JavaScript application where you click on the purchase button, right? And that will only work once.
But you could reload the page and buy it
Yeah.
over if you want. Yeah.
Yeah.
And then can you undecorate something once it's decorated?
I don't think that you can. There might be some convoluted way to, add another decorator that allows
Just not.
you to undecorate, but yeah.
So would it be more, would the use case be, because in that case, you could just program it the way you wanted in the first place, but if you're adding different decorators to a bunch of different things, that might be why you would want to use a decorator instead of just hard coding it into the function in the first place?
Yeah, so the use case here would be, I guess, ideally there would be several functions that would need to be restricted or modified in this way. Otherwise, you could just include this logic here.
So you might have a sell and a buy and I don't know what else. That makes sense.
Yeah, so you could do all kinds of testing. So, decorators can be used for logging. So anytime you call the function, it logs the parameters it was called with and so on. You could, you could use it to check for, so actually I think I have, let me see, I have another example real quick. Yeah. So here's another example. Again, this is also contrived. But let's say I have a function and I only want to accept even numbers as parameters, right? Totally contrived. And let's say, again, I could include that logic just in this add function. I could say, if whatever A is not even, then throw an error. If B is not even, throw an error. But presumably there are lots of functions that want that kind of check. So rather than writing that logic over and over and over again, I write it in one place here, and then I decorate the functions that need it. So if I run so again, I'm throwing an exception, but you don't, this is just, this could be anything. You could just return none or. So again, this is the same basic structure where I have a function, right? That takes in this decorator is a higher order function. It takes in a function. It grabs up all of the arguments, in which case there are 2. And then this doesn't matter, but it's this is just doing a check. kind of just to see if it's even, and if all of the arguments are even, then it will just execute the function normally. But if any arguments are not even, then it will do something else.
So it's interesting that it's not really like checking the arguments and passing them to the function to run. It's running the function within the checker function. Does that make sense? Like it's not like taking the arguments and then passing it to the add function to run,
So
going inside of itself.
So what's, I'm not sure I totally understand, but let me just explain and then you can ask your question again. So what this is doing is similar to what we saw with the currying example. So it's basically preloading. So when we add the decorator and we're calling, again, we can't see this, but add is now basically, so this function add is now, let's do, I'll just call this like this. Let me undo the decorator here. Print that. I get 6, and if I pass it an odd number, then I get an exception. So again, this is, you know, syntactic sugar. It's a nice way of shortening the work you have to do, but it's basically doing what we saw before, where it's kind of preloading this function here. And then every time you execute it, this, yeah. So does that help at all?
Yeah, I'm not, I understand. I think I understand what I was asking. It just, I'm not sure it matters. I was just, if there's a chain that goes in, it doesn't matter. Yeah, it makes sense.
Okay, so I'm gonna say let's take a 10-minute break, and we come back, we'll talk about generators for a little bit. Okay, so the last thing I want to cover today in lecture is generators. So generators are everywhere in Python. So a for loop, so any kind of, well, I should say that a generator is a specific kind of iterator, and iterators are everywhere. So what is an iterator and a generator? Well, let's go ahead. Let's try to write a for loop. So for I in 9. So what's going to happen when I try and run this?
It should count from 0 to 8.
Okay. Does anyone else have any guesses?
I think it's going to get confused because it's just 9. So it's just saying the number 9 and there's nothing to iterate over.
Okay. So
It might just print 9.
okay. All right, cool. So we've got some good hypotheses going. Let's run and see what happens. Oops. Oops. Okay. So we actually get a type error. And the type error says that an int object is not iterable. So 9 is an int object, and 9 is not iterable. So what does that mean? So I'm going to go into the interpreter here. Is this, can you guys see this? Is this too small? Okay. So I just want to see all of the stuff that 9, that this an integer 9 has available to it. There's all kinds of stuff, right? I can get the absolute value, I can add it, I can, I'm not sure what and does. Oh yeah, it's probably the ampersand operator. I can delete it. I can see if it's equal to something else. But we want to see if it has an iterable. So it doesn't look like there's anything that could be an iter or an iterable. Alternatively, we'll look at an empty list. We see it has, it's a different set of things, right? These are different objects, so not surprising, they have different stuff. And we see right here that we have this iter dunder. So if we have an array, then we have access to iter, unlike a number. So this error message is telling us basically that int doesn't have dunder iter. That's basically what that message means. So what does that do? So let's take a look. I'll write this out here. So we'll just create a list, and then let's see what. So there's a couple ways we can call. So this is basically like a convenience function, which is actually under the hood going to call this. So that's the same thing. We'll see that. And we see that we get a list generator object. So that's we have another. So this is an object, and when we call iter on, we call it this iter dunder method on it, we get a new object. So let me do. So these are not the same, right? So my list here, when I call iter on it, which by the way is what a for loop is going to do, I actually get back a different object. And this iter object has a different set of things. It's got, interestingly, it also has its own iter. That's strange. It should have, that's weird. It should have a next as well. So in terms of what makes an iterable and iterable, the two important dunder methods are going to be iter and next. So what actually happens under the hood, and again, you don't really need to know the details. I'm just giving you this background, mostly because I think it's interesting. But so when you call iter on something, an object, right? This is an instance of a class. This is an instance of Python's built-in list class. This list class has a dunder method called iter. So you can call this iter method. When you call this iter method, it returns another object. And that other object has a next dunder. So let me illustrate that real quick. So X and again, this is a convenience for this. But let's see what happens when we print. Well, let me, first off, we'll populate this. I'll comment out these. And I get a 1, which is the first item here. So let's call next again on this X iterator object. And I get 2. And let's call again. And I get a 3. And what happens if I call it again?
You'll get a 4. Oh, actually nothing. You might get an error.
Okay. Let's see what happens. We do get an error. We get something called a stop iteration exception. So actually, when you run a for, every time you run a for loop, you're creating an error. You're generating an error. But it's just handled. You know, it's part of the expected API. So this is what happens when you call a for loop. So all this stuff is, you know, whatever. What you're actually doing here, if X is an iterable, i.e. if it's an array or a tuple or a dictionary or whatever custom thing you make that has this API in it, the for loop is going to first call the iter. It's going to call the iter dunder on whatever this thing is, and that's going to return a new thing, which is going to have a next property. And then every time it's going to keep calling next until it gets that stop iteration error, and then it's going to exit. So that's actually what's happening when you use a for loop. So that's more general kind of background. So let's try fixing. So our first example, where we tried to print, I'll copy this again. Right? So this doesn't work in Python, but we can, of course, we can customize everything. So let's try to make this actually work in Python. So first thing I'm going to do is I'm just going to copy this, but so we're going to create a new class. It's going to be a special kind of integer, and this integer is going to be iterable, because regular integers in Python aren't iterable, which means that they don't have the dunder iter method. So the basic requirements are pretty simple. If I want to make something iterable, all I have to do is implement this dunder iter method. And this dunder iter method will return an iterator. What is an iterator? Well, we'll create another class that's an iterator. But as a first step, this is really, so we just have to follow the protocol or the rules or the API for how Python does things. So if we want our thing to behave like an iterator in Python, then we just have to make it conform to the basic expectations. So we have an iter, And let's go ahead and implement this int iterator. So the iterable, so I know it's confusing, like iterable, iterator, all this stuff. Unfortunately, there's not much I can do about that. I think I've modified this slightly. Yeah, that's fine. Let me comment this out for now. Okay, so we have we have an iterable, which just means that it implements this iter, and then it returns an iterator. So what does an iterator have to have? What are the requirements? What is the protocol for an iterator? Well, basically all you have to do is implement next. You should also implement, it's a little weird, but it should also be able to return itself. But this is really the important thing. So notice the basic structure here. We're going to try to do something. We're going to try to, get a value. And if it's not there, then we're going to raise stop iteration, just like the built-in Python stuff, right? So if we try to keep getting stuff and we run out of stuff to get, then we get this stop iteration exception. So we're making our own custom object behave just like built-in Python stuff. So I mean, this is just a silly example. So, but now we have our own iterator implemented. So we can create an instance of iterable int. We just and we'll see what happens. Yes. So what I'm actually doing is basing on the length. It's just silly, but that's why I don't want to have complicated logic. Terminal's being wonky. So I mean, so again, like we could implement more complicated logic. Feel free to try it out on your own to actually get something that would be what you would expect, like 9 times. But here we're just using the length. But it does call it. So I have a custom object that I've made, and I've just thrown it in a for loop, and now it behaves like a normal iterable in Python. Okay. So that's iterable. So another way of doing the same thing or something very similar would be to use a generator. And a generator is basically the same thing. It's going to behave in the same way. I'll comment this out. And a generator function looks just like a normal function in Python with one exception. Instead of returning, it's going to yield. So you don't return, you yield. And yield is basically it's going to go through, it's going to return or yield this value, but it's going to keep the state. So it's almost like a closure, right? It's going to preserve its state. So if I have a function here and I pass in a number, right? So again, this is a silly example, but this will do the same thing because this yield statement will make this a generator, and under the hood, Python will do its magic, and it will make this, it will turn this into an iterable. I can run this again. And I get 2, 3, 4. Whereas if I just had a function, if I just returned, then I'm only going to get one value. But yield. And if I print the function iterable num, so I call it and it returns or yields a generator object. So this generator object will conform to the iterator protocol. So why would you ever want to do something like this? Well, Python does this all the time. So Python is full of iterators, iterators and generators and stuff like that. So one use case would be if you want to work with data that's bigger than what your memory can handle. So this obviously isn't going to be the case for stuff we do in class, but if you ever want to like read from a CSV or a database and there are millions of entries and you want to process that data, maybe you want to run regular expression check on every item of data, you can't just assign all of that stuff to a variable because your computer doesn't have enough memory to do that. So you would need to use a generator. So a generator is lazy. It's what's called lazy. So you have this idea of eager and lazy. So let me grab this infinite sequence. Okay, we'll talk about this and we'll talk about lazy and eager. So here I'm creating a generator, and it is just going to keep producing an infinite number of numbers. So if I put this in a for loop, the I should be like n. I'll run it. Anyway, this is going to break probably. Okay, cool. So, so again, this will just keep running forever and ever and ever, right? It's like an infinite for loop because this is just going to keep yielding over and over and over and over and over again. So what if I tried to put this in a list comprehension, for example? So I'm going to do that not on my computer. I'll break someone else's computer. So I've got this right here, and then I'm going to create a list comprehension, right? So I want to create an array composed of, I guess, infinite numbers. So what happens when I try to do that? Depending on, your mileage may vary. I actually haven't run this on my computer just because I don't want to, but feel free. You want to try it, you can tell everyone what happens. We'll probably get a memory error. If we wait a second, we'll also get, this just says REPL process died unexpectedly. So we're getting an error, right? Because we don't have infinite memory. So at a certain point, this just isn't going to work. So this could represent a very, very large file, like a CSV file with, 20 million entries. So I couldn't just read the file and then for every line in the file, create an entry in the list. So that won't work. So what we could do instead is create not a list comprehension, but a generator expression. So big change, instead of brackets, it's parentheses. So now if we run this, nothing happens, but we can use X. X is now basically an iterable. So for whatever n in X, I'm also gonna stop this, but now what I've done, if this were like, if this were reading from a file object, it wouldn't actually be infinite, of course, but I would be able to one at a time process. So that's lazy, right? I ask for things one at a time as I need them. I don't just say, hey, make me a list of everything right now. I say, hey, can you give me the next thing on the list? And then I process that and then say, hey, can you give me the next thing on the list? And so on. So I'm not using up a whole bunch of memory all at once. So that's the basic use case for this kind of stuff. All right, so that's all I've got for generators and iterators. So that's more kind of, that's a little bit less practical for our purposes, but I just wanted to talk about that. Are there any questions?